as we get ready to study calculus, one of the things that we'll need to know how to do is identify key features of graphs. And one of those key features is points of intersection. This is actually a topic that you probably got familiar with in Algebra 1, but I'm guessing you might be a little bit rusty on it. So by the end of this lesson, you'll be able to find the point or points of intersection of two graphs. Right, points of intersection are basically points that satisfy both equations that we have, and it really is just where two graphs cross each other. So just as a real quick example, if I've got a parabola and I've got a line right there and right there, would be my points of intersection. So we're just going to go right into examples. There's probably several different ways to work these problems, so I'm just going to do the ones that kind of pop in my head when I do them. This first one, to find the points of intersection of the graphs, you'll notice that these two are graphs of lines. And the easiest way to do this one would just be elimination. You'll notice if I add the two equations, my y values would cancel out, so that's exactly what I'm going to do. So when I add the two equations, I'm just going to add like terms. 2x plus 5x would give me 7x. Negative 3y plus 3y would give me 14. And then divide both sides by 7. I get x equals 2. Of course, I'm not done because I need to find out the y value that goes with the x value. So I'm going to go into either equation. I'm going to actually go up into the first equation. So wherever I see an x, I'm going to put x equals 2. And then I'll just solve for y. So I'll get 4 minus 3y equals 13. To solve for y, I'll subtract 4 from both sides. So I'll get negative 3y equals 9. Then I'll divide both sides by negative 3. And we'll get, y equals negative 3. So that tells me that these two lines cross at the point 2, negative 3. And that makes sense because if we have two lines, they really can only cross in one place unless they cross all the time. So there we go. Okay, next example. This time you'll notice we have something else going on because we have an x squared. That's actually a sideways parabola, just in case you were wondering. And we have a line. I'm going to work this problem two different ways. The first way that I'm going to do this problem is similar to the way that I did number 6, using elimination. I'm going to multiply this top equation by negative 1. So I've got negative x squared plus y equals negative 3. And the reason that I did that, because now if I add the two equations, excuse me, y values will drop out. So when I do x minus x squared, I cannot combine those because they're not like terms. The y's cancel out, and then 1 plus negative 3 is negative 2. Now to finish solving this, it needs to say equals 0 because I'm kind of looking that I can factor. Excuse me. So what I'm going to do is add 2 to both sides, and I'm going to write it in standard form. So I'll get negative x squared plus x plus 2 equals 0. We cannot factor when there is a negative in front of the leading coefficient, so I'm going to actually just multiply the entire equation, by negative 1. So I'll get x squared minus x minus 2 equals 0. I can now factor that into x minus 2, x plus 1 equals 0. And if you're having a little bit of trouble factoring, please refer to my factoring trinomials video. Now using the zero product property, I get that x will equal 2 and x will equal negative 1. So this time we got two answers, which means these two graphs must intersect in two places. So now again, you can go into either equation. I'm going to, I think, go into the second one. It looks a little bit easier, and I'm going to plug in 2 for my x. So I'll have 2 minus y equals negative 1. Just equals 1, excuse me. And then we'll subtract 2, so I'll get negative y equals negative 1. If I multiply both sides by negative 1, I'll get y equals 1. Okay, when x equals negative 1, I'll get negative 1 minus y equals 1. This time I'll add 1 to both sides, and I'll get y equals 2. And then multiplying both sides by negative 1, I'll get y equals negative 2. So these two graphs intersect at the point 2, 1, and then also at the point negative 1, negative 2. So they intersect in two places. Okay, I am going to show you a second way to work this problem. I'm just going to get it set up for you. Another way that I could have worked the problem. You write the problem here. Okay, I could have taken this top equation right here, and I could solve it for y. So I could subtract x squared from both sides, so I could have negative y equals 3 minus x squared, and then I'm going to multiply through by negative 1, so I'll get y equals negative 3 plus x squared. And now what I can do is go into the second equation. It's just called substitution. I can go into the second equation and plug this expression in, this evaluation in for y. So I'm going to have x minus the quantity negative 3 plus x squared equals 1. And then I'm just going to get rid of my parentheses. I'll get x plus 3 minus x squared equals 1. And then again, I'm going to set it equal to 0. And if I do that, I'll subtract 1 from both sides, and I'll put it in standard form. I'll get negative x squared plus x plus 2 equals 0. And notice it got me to the exact same spot that I was at over here. And then I could finish the problem exactly the way that I did. So either way is fine, just whatever way you're most comfortable with. And that is how you find the points of intersections of two graphs.